Right, let's take a look at question 3 then. So this is a moments question. A uniform beam AB has mass 20 kilos and length 3 meters. So the fact it's uniform means I know that its center of mass is going to act at the center of the length. The beam rests in equilibrium in a horizontal position on 2 smooth supports. One support is at C, where AC is 1 meter, and the other end is at B. Beam is modelled as a rod. Find the magnitudes of the reactions. Okay. So there's my beam. That's C. That's B. And I'm going to have a reaction at C. And I'm going to have a reaction at B. And the mass is going to push the weight of it down through the center. So I've got AB of mass 20, beam rests there, and there's no other weight acting on the system. So if we've got a 6 meter length in total, and that's 1 meter, then from there to there is 3 meters, which means that distance is 2 meters, and this distance is 3 meters. System's in equilibrium. So therefore, the sum of the y component forces will be 0, and also the sum of the moments will be 0 too. So for the sum of the, not the x components, the y, so the sum of the y forces means you've got RC plus RB minus the weight equals 0. So I've got RC plus RB equals 20G. So that's equation 1. I've got 2 unknowns in that, so there's no more I can do. So now I'm going to take moments, and I'm going to take moments about either C or B. Doesn't matter which, but in doing so it will mean that RC or RB, wherever I take the moments from, will not appear in the equation because the distance of the moment is 0. So it's going to take one of those unknowns out. You could take moments from the end, but if you do that, you're going to have another equation with both RC and RB in. So I'm going to take moments about C. So remember what I said in the revision lesson last time. Sum of moments, I'm taking that direction turn as positive about C. So about C, I've got RC times 0, which is why that goes. Then I'm going to come to this force here, which is the weight, so plus 20G times 2, and if I'm pivoting there, that weight is trying to turn the system in a clockwise direction, which is the direction I take to be positive, so that's plus. Then the other force is RB. That's 5 meters away from the pivot I'm measuring from, and RB is trying to turn it in an anti-clockwise direction, so that will be negative, equals 0. I got 3 forces in my system, I got 3 aspects to my equation. So this now works out, that's 0, so I got 40G minus 5RB equals 0. So RB will be 40G over 5. 5 goes into 40 8 times, so that's going to be 8G, or 78 newtons to two significant figures. So once I know what RB is, I can sub that in 1, and RC will be 20G minus RB, which is 8G, equals 12G, which is 120 newtons to two significant figures. So that's part A. Part B now. Part B, let's redraw the diagram. Because what happens now is you've got a body of mass 30 kilograms standing on the beam at the point D. The beam remains in equilibrium. The magnitudes of the reactions on the beam at B and C are now equal. So now I've just got R. I've still got my 20G acting centrally, and I've got a boy of mass 30 kilos who's standing somewhere and we don't know where. So if I put him there, he's got a mass of 30 kilos, he's got a weight of 30G newtons, and I want the distance AD. So A is here. So if I say that AD is X, this time it's going to be better to take moments about A. Still in equilibrium. So our sum of our forces is still 0. So this time the sum of the vertical components will be R plus R minus 30G minus 20G equals 0. So 2, R equals 50G. So each of those reactions is 25G newtons. Now I need to take moments about A. So the first one is R times 1. And R is trying to turn that in an anti-clockwise direction, so it's minus R. Then I'm X distance away for the lad who's standing on it. So 30G times X, that's a clockwise turn, so it stays positive. Then I'm to the center of the system, so 20G times 3, because that's halfway along the plank, and that's also trying to turn it clockwise, so it's positive. And then the final force is this reaction, R, and that's times 6, because the length of the plank is 6 meters, and that's trying to turn it anti-clockwise, so that's negative as well, equals 0. So I've got 1, 2, 3, 4 forces, 1, 2, 3, 4 aspects in my formula, in my equation. So I'm happy with that. I've got a 6R and a 1R there, which is 7R, which I'll take over to the other side. And on this side I've got 30GX plus 180G. Sorry, what am I doing? 3 2s is 6. 60G equals 7R. 30 gx plus 60g. So 7r, I've worked out that r is 25g. So that's going to be 7 lots of 25g. That means I can divide throughout by g. 30x equals 7 lots of 25, 175, minus that 60. So x will be minus 60 is 115 over 30, which is 3.8 meters. So that's question 3.